Afternoon, everybody. Welcome to this Network Shop 49 sponsor session. I hope you're enjoying the conference so far. I'll just wait a few seconds for any last few people to join. Okay, let's get going. So I'm Neil Shuri. I'm head of delivery for the Janet Network, and I'm really pleased to introduce Alex Gittings from Axians to this session. Axians are a key partner in the delivery of Janet. They provide specifically and support the core routing platform on Janet, as well as providing key components of the Janet managed router service. So both really critical in the operation of Janet and also the provision of service to members. Today, Alex is going to be talking to you about how to get a head start in network automation. So without further ado, over to you, Alex.
Thank you. Hopefully everyone can hear me okay. I will just switch up to my slides. So yes, how to get a head start in network automation or using network discovery to get started with network automation. And I'll be talking about some key areas that we like to focus on at Axians, as well as other companies in the industry that are looking at focusing on network automation. And I can see by the schedule of this week's presentations, there's a large focus on network automation. So again, jump into any of those sessions, which will also have some interesting discussions around network automation. So who am I? I'm Alex Gittings. I've been at Axians for almost 3 years now. I joined straight out of university, and at university I studied at Birmingham City University, and I studied computer networks, so the degree in computer networks, mainly centered around the Cisco curriculum of NetCAD, but also did my JNCIA for Juniper and so forth. During that time, I took a placement year and I worked at Cisco for 18 months. 12 months of those were in solution. 12 of those months were in full-time in Reading, a part of the solution validation services, where we tested customer networks in controlled environments when they purchase a solution from Cisco. The rest of that time, I worked at Cisco part-time as a PHP developer on one of their internal IPAM tools and data center management tools that managed essentially the labs across the globe for validation services. And it used to be called validation services, now called something else, but that's what I like to go by. Also, during my time there, I looked at cloud and NFV technologies, so network function virtualization. So how do you virtualize routers on the edge and security appliances at the edge of environments? And I also show a bit about what I do at Axians as part of that. So my day job, I'm a professional services consultant. Again, been here about 3 years. General routing and switches is my core, essentially bread and butter networking. It's what Axians focus on. And as part of that, we also do deliver a plethora of SD-WAN and UCP technologies. So working with customers to implement SD-WAN, multiple SD-WAN vendors. As well as UCP, so Unified CP, I talked earlier, I've done a bit of NFV, so also working on UCP environments, Unified CP, of deploying virtualized routers, NFVs to edge environments on edge compute, so that we can have one piece of tin and swap out the network components as and when needed. And as well as that, I do a lot of the network programmability to help customers foster network development, the development of network automation and programmability into their estate, as well as training and specific projects that we work with customers to achieve. So what's the problem with networks at the moment? And there's a lot of problems. These are just ones that we've come up with. First is complexity. There's multiple different networks within one organization. Within HE, you've got your cloud networking, you've got your data center environment, you've got your what your IT environment, your campus environment, and all of those require different technologies. You've got your cloud networking. You have to look at how you interact with cloud environments, Azure, AWS, in a network capacity, as well as maintaining your own data center, whether that's traditional VLAN or going up to new VXLAN and so forth. And each one of those is complex and requires a different tool set to do the job. There's also a lot of technical debt, something if you've got a legacy network, something that has been applied over time, patches and upgrades that have kind of stayed in the environment that were only supposed to be there for a week or two in between the next migration window are still there, and can be a pain to get rid of if they're combating a certain issue. You have to correlate some of the patching with upgrade schedules of if you put a workaround in for a specific bug that you experienced on a specific version of hardware, and then a newer version has come up that fixed that bug, but you've still got that patch, that workaround from several years ago. So there's a lot of technical debt that can come with networks. Quality. The quality of configurations are not always the best, and a large part of automating a network is getting that quality and being able to replicate networks is really key. Visibility, insight. We all see with the cloud networking these days, you can click on portals and so forth and see the network in different lights, and there's also other tools that allow you to do that. But traditionally, you've got a CLI platform, or you've paid for a management solution that gives you insight, but it only gives you insight to that one place, that one little facet of your network, not the whole thing. Compliance. So complying with different standards, ISO compliance, and different compliance for regulators that organizations and higher education facilities need to comply by. Then there's also manual operational processes that are in place that can be quite cumbersome. You need the right people on the job to do that specific task. If they're messing with MPLS, or you need someone who knows MPLS. If you're doing some BGP manipulation, you need someone who knows BGP in depth and so forth. And manual operational processes can be quite complicated in traditional networks, depending on the environment, of course, and who takes ownership of those processes. So introducing network automation can be a pain, and that "can" is emphasized. It's a large task. Everyone talks about network automation, and it is a very complicated area of networking, and it's not to be seen as like a small change. It's a big industry-wide change that's happening at the moment, and a lot of people talking about network automation. So what are they? Firstly, where do you start? Do you start by thinking about what we can automate? Do you do read-only tasks? Do you look at a manual operational process that is really taking its time and taking its toll on the network team and the operations team? Where do you start? Next, do we have the skills to actually start? So first off, we've got to start training. Do people know common configuration management tools, Ansible, SaltStack, Puppet, Chef, all these different platforms? Are people aware of them and know how to use them? Then you could get into the deeper assets of network automation, which is essentially programming. Your network engineers are going to start turning into network programmability engineers. Juniper likes to use the term network reliability engineers, which stem from site reliability engineers that Google coined several years ago. And being able to make sure that the network is reliable using up-to-date methods of the DevOps processes and so forth. So training, where do you go for that training? We have providers like ourselves, Axians, that do training, but also is it training related to your environment? Is it training relating to things that you want to do? And some places are different to others. Low-hanging fruit. What do we tackle first? Do we tackle those painful processes that we talked about earlier, and making sure we can ease the burden of the operations team and make sure it goes for different change processes go further, and operational processes are easier to go through in future? Read-only operations. Don't make changes to the network. The best thing for network automation is that we can get data from the network and make it easier for people to do things. If there's a ticket that requires finding out what routes you're advertising to a network, instead of having an operational process that's, it's an A4 piece of paper, go log into these routers, do all these commands. Maybe we automate the read-only processes and give data to the teams that need it, and make that data accessible. And business integration. If someone requests a service from JISC or a department within your university or and so forth requests a service, be able to integrate with the different parts of your business and be able to provide a service that's customizable for your different departments, and really integrating with the processes that you have internally, to get the best out of automation. And these are all things that take time, but eventually they get there. So we're going to look at some statistics, and people never like to look at statistics, so we'll try and make it as fun as possible. So Juniper have a report called State of Network Automation, called Sonar, and essentially this is a report that is gone for the past 2 years, that essentially queries and questionnaires sent to their customers to ask information about automation in their customers. And this graph here essentially shows the level of automation within their customers. Now we're looking mainly at the right-hand column. Enterprise, higher education and so forth sits within that enterprise column, but we also have the other industries, CSP and cloud provider, in here. And on that right-hand side, we see that a large percentage, we're talking over 50%, are either not automating or just beginning to script the CLI, as in, everyone's got a putty or secure CRT where the compressor button and it'll paste in a bunch of commands and you get your output and so forth. So you've sent it to a log file, just that beginner stuff. So about 50, just over 50%, 54% are just getting in, just not automating or just doing the basic CLI. Then on the top right hand side, we also see that there's a smaller percentage, 12%, that are automation in production in all places. Now, that's a very tough thing to do, and a lot of those are greenfield networks that they've put in a new network along with a management platform and so forth. But some are getting into that space. They've got a lab environment that they've started running scripts on, or they're in production in some places, probably the data center where people are swapping out requirements and so forth. Down the bottom set of graphs show how many over time, how people have got into automation and how people are automating over the years. So we can also see a large percentage of that right-hand graph, the enterprise, within the first year to 2 years, essentially. And I think that's because of vendors such as Juniper are pushing Netdevops and network reliability engineers and training courses and so forth that allow you to be able to upskill in network automation and show the benefits of their platform, essentially. And then again, you've got the other side. The more time it correlates, the more time that you've been doing network automation, the more places that you've got it in your network, essentially, and the more skilled you are and the more experience you are at putting that into your network. So there is also another company that runs a questionnaire, and that's Network to Code, based out of New York, and they do the Netdevops Survey, and this statistics is from 2019. But it says, what operations are you currently automating in your network? Configuration generation is pretty much the biggest one. When you get a piece of kit from your vendor and it's just got delivered, you've got to now configure that with potentially hundreds of thousands of lines. In my case, working on a project at the moment, hundreds of thousands of lines for one device. How do we do that more efficiently? It takes time. Configuration deployment. Once you've got that configuration, we want to push that to a device. Maybe you're swapping out a like-for-like device. Maybe you've backed up the config, but you want to push it again. A lot of people are doing that. Configuration archiving, data collection. It goes down the list, and a lot of people are doing those. You get right to the bottom, and you find as the further you go down, the more advanced the automation operations are. Fault remediation, everyone wants that, but you've got to be doing it for a long time. You need all the previous things in place before you can do the next, the bottom one, essentially. And it goes down. You need configuration generation before you can deploy it. Once you've got devices deployed, you can start archiving. Once you've archived that, you can start collecting data and doing compliance checks on that data, and it goes down. They also do another survey that says what kind of tools, deployment configuration tools are you using to deploy this information into the network? And we can see here that we've got custom scripts, and we can see that a lot of people are starting to use custom scripts, but also we can see a huge spike in Ansible in the orange column that shows a lot of people started using Ansible in the last a few years since their last survey. It's really took off in that orange column there. We've got Napalm in there. We've got SaltStack. We've got Cisco NSO. We've got other controller-based software. Terraform right at the bottom for your cloud environments, cloud networking. And it just shows the different tools that are out there that a lot of people, and you can see the industry trends in here of where people are going for their network automation tooling. And we can see pretty much 90% of them are open source tools. Here we got NSO, we got HP network automation. We've got a few in there that are essentially vendor products, but a lot of them are open source. So that's all a bit too much. So what do we actually want? There are a lot of network automation possibilities, and the list goes on forever. We got topology mapping, chat ops, intent-based automation, source of truth. And when all of these different things allow you to have a fully automated network, proposing changes and seeing what that change has an effect on the network, being able to get that data via a chat application, so that instead of IT, a department within your business coming to you and saying, can you check this? Can you check what VLANs are on this device? They can request the information through Teams or Slack or whatever chat-based system you want, or portal-based system. A ServiceNow request form, so that they can get the data automatically through that. Source of truth. Where do you store your data? Do you use like a DDI tool, an IPAM tool, and there's many out there? Do you use open source tools like Netbox and other tools out there? It's one of those things. There's a different platform for whatever you want to do, and there's choice. There is a lot of choice. Our problem is that we're a provider of professional services, and a lot of the time we get involved in network automation projects, and a large time of discovery, like essentially a network automation project, is that we want to go from zero to hero. We want everyone wants the maximum they can get, but then you realize the time it takes to get there is actually quite a lengthy one, and we want to shorten that as much as possible. One, it reduces the cost for the customer, but also reduces the time that we have to invest in that, so we can work with other organizations to foster automation and programmability within their network. So we were spending a large time of projects discovering the information that is out in the network, mapping a topology. When we engage in a project, we have to fully understand your network, every bit of config. We have to work with the teams to have training and so forth. It's a lengthy process. What we thought of is a way to cut down a large percentage of that time and focus on being able to discover the network automatically. And essentially what we have done is partnered with a company that we really like, that helps us do that and allows us to get started on the automation journey sooner. We've partnered with a company called IBM Fabric, and essentially that product essentially allows us to discover the network. It's a network discovery tool, and it can discover legacy SSH-based CLI command-based products, but it can also interact with other products, SD-WAN technology, VIPTELER. VIPTELER got released in the latest version, got Meraki in there, and things are also on the board. They've just released AWS support, so they can map a AWS networking, and Azure is also on the roadmap. It takes all the data from those different data points, essentially. As I said, you've got your data center, you've got OT, all these distributed networks, analyzes them, and then puts them into a multi-database model. And what we can do a lot of stuff with that multi-database model, and I'll show some key points. It comes with a web UI so that we can visualize, search, and get information from that documented discovery. But we can also use its API, and that's where we've seen huge potential in this software, so that we can use Ansible, PRTG, SolarWinds, ServiceNow to all integrate into this product, so that we can get started on the automation journey for our customers. Essentially, the dashboard of this product, you allow this product to discover your network using read-only credentials. It will map the health of your environment. It will map your vendors, your layer 2 health, layer 3 health. It'll give us information. We can see on there we've got the intent verification rules at the top here, and that shows different verification rules that can be customized for a user to show and highlight the data in the tables below about that. So we can see memory usage on specific devices is quite high, and that shows up as red. But we can also get all this data via the API, which is awesome. It will graph our network. Now, the photo is pretty small, but we can turn off layer 1, layer 2, layer 3. We can overlay BGP onto those, and we can also overlay our intent verifications on the previous slide onto this diagram and show, okay, this device is not healthy because spanning tree priority is set incorrectly, or set at a threshold, or different timers are incorrect, and we can overlay that on top of this network. It's very, very, very cool. It will also show you operational state information. So it's not just analyzing config, it's analyzing the data within the network. It's looking at your OSPF neighbors. It's looking at everything else in between. Now, it's a brief stop tour of why we've chosen this. It's very comprehensive, has a lot of data, produces reports, diagrams, everything. And how are we using this to perform automated discovery and validation? So essentially, our problem was that we had a network. We needed to start automating it as fast as possible, get data out of it, and that tool allowed us to get the data as soon as possible, and it's very quick. So we can have IP Fabric, and we built custom tools to leverage into Netbox. Netbox is an IPAM / data center management tool, DCIM. And it allows us to manage our sites, racks, layouts, interfaces of devices, inventory, and so forth. So we've built a tool, a plugin for Netbox, that allows us to pump all the data from IP Fabric into Netbox, and it will show us what the network is supposed to look like from your source of truth point of view in Netbox, and show you if any differences are in there, and I'll show that later on. And then what we can do with that is start using dynamic inventories in popular or configuration management tools to query the data out of Netbox and start generating configuration. So we can see here that we've discovered a network using IP Fabric, pumped all the data into Netbox. We can start changing parameters in Netbox, and then have Ansible or another configuration tool to then start crafting configurations. We've also open sourced our own dynamic inventories for Red Hat Ansible and Nornir that have been released by Axians to allow you just to query IP Fabric directly. An example workflow of how we can put this into the frame is that we have IP Fabric discovers the network. We pump all the data into Netbox, Git, or other sources of truth, such as VLANs, interfaces, IPs. We have Ginger and Ansible to take that data and turn it into a desired configuration. We can push that desired configuration to the network, but at the same time, we can tell IP Fabric, I've changed these devices. Please go and update your information and do all your verification rules. And it'll go and query the network, analyze it, create your new topologies, create your live documentation, do analysis, and so forth, and many other things that can do. And we've just ticked off essentially a nice workflow that allows us to, one, configure the network and verify it very quickly. So our IP Fabric Netbox integration allows you to bootstrap a source of truth. Uses the Netbox plugin framework. It's driven by the API. It can ingest data from IP Fabric into Netbox. We can compare proposed changes between the IP Fabric has discovered and what Netbox knows about, and we can choose to either discard or commit those. So essentially, this here is a quick overview of how we can install IP Fabric for Ansible, and I'll just skip through this because we're limited on time. But essentially, once it's installed, we can generate an API token in IP Fabric. There we go, get an IP token from IP Fabric. I'm going through this pretty quickly, so any questions, just let me know. Put an API key into our dynamic inventory file for Ansible, and we can see that when we list this out, we get an error first because we haven't got a cert on our demo instance. So we just change that to false, run that command again, and we can see that our Ansible environment now knows about everything in our network using a dynamic collection, a dynamic inventory for Ansible, and that's open source. Quick one here about how we ingest data. We've got 2 minutes left, so let's skip through this one. So this data here, this is what IP Fabric knows about. It can discover the network, has a bunch of data in it, and I'll just go skip ahead. We have an empty Netbox instance, totally empty, and we have a custom plugin, and on the right hand side we can press ingest on the top right hand corner. We can press this ingest button. What this will do, it'll query IP Fabric for all the information it knows about, and there's only things that we have implemented. And you can see it was pretty quick, and it shows us the different bits and pieces. It's discovered 1,600 interfaces, sites, a number of devices. But this hasn't actually implemented into Netbox, so we can see there it's verifying that 1,600 interfaces has shown up correctly. If we go back to Netbox, here we can see that Netbox is still 0. The homepage of Netbox, it all shows 0. This is because we can choose to commit the changes or not. We press the little diff button. This will go and compare Ansible against IP Fabric in this case, because it has both sets of data. And then once we're at that point, we can see here we get a differential table, and it shows you all the devices we want to add. And we can see that the proposed changes essentially. Once you're happy with that, you can go back, approve the data, and it'll go and update Netbox's database. And you can see that all the data essentially gets populated. So here quickly, we've essentially bootstrapped a source of truth very quickly. And you can go into a device, it's created all the interfaces, put the descriptions for the interfaces, hardware components. So if you've got chassis, it will do all your line cards, your power supplies, everything like that. And it's put it into your source of truth very quickly. Also additional information in there. So, end of sale for your sales guys, maintenance, end of support, all imported from IP Fabric into Netbox, so we can show all that cool data. Chat ops. very quickly brief on this. We've got chat ops. We can essentially query the network using chat and get that data into a nice tool. Quickly going over this, got a few seconds left. Essentially, I'll show you the stats page at the front. This is what we ticked off. With IP Fabric included, we've ticked off all these green bits so we can focus on the purple bits that we really want to start delving into in a network automation project. So essentially, thank you very much. Axians, come and speak to Axians. We can help with anything if you want. Some links there if you wanna look into anything.
Thanks, Alex. Really interesting and really comprehensive look at, I guess, both theory and practice of automation. Yeah. So there aren't any questions in the Q&A, thankfully, and I expect everyone's their lunch. Yeah. Given the time, yeah, I mean, obviously on your slides there was where to get more information. I imagine your details are somewhere in this system for people to contact as well. So I'll just say thank you one more time to you. As I say, really interesting, and I hope you and everybody else enjoy the rest of the conference. So thanks very much all.
Thank you very much.